Hello everyone. In this video, we will learn how to find tangent line to a polar curve. Well, I will start with one example. You'll see that the trick that we use, you already know it. Well, I have a polar curve, which is cardioid. And I use that to express my polar curve as parametric curve. In other words, r is given in terms of theta, so I will plug in that into the formula for x and y in terms of r and theta. So this will be x equals to 1 plus sine theta times cosine theta. Y is going to be 1 plus sine theta times sine theta. This is parametric equation. Well, and we have used this trick actually when we were trying to find arc length of polar curves. So I go ahead and use the same trick because we know that the slope of tangent line is the derivative at that point. But since this is parametric equation, in the parametric equation's case, we have a way to find that derivative. So we first find derivative of y with respect to parameter and find the derivative of x with respect to parameter and then divide those ones. Now that I have everything there, I go ahead and differentiate derivative of y with respect to x. This is product rule. First one is cosine theta times second one plus the first one itself times derivative of sine, which is cosine. Here, for x, derivative of first one is cosine theta times cosine theta, second one, plus derivative of the second one is negative sine x. So that's why I put negative. The first one itself times the second one. Okay. So this way I have a formula for the derivative in terms of theta. Well, actually I can simplify. Let me just simplify this a little bit. Here in the numerator I have 2 sine theta cosine theta. You see that this and that will give me the same thing, plus cosine theta. In the denominator, I have cosine squared theta minus sine theta minus sine squared theta. Okay, so this way now I can go ahead and use that formula. So m, the slope, is going to be plug in theta equal to pi over 4. So in the numerator it will be 2 times root 2 over 2 times root 2 over 2 plus root 2 over 2. In the denominator we have root 2 over 2 squared minus root 2 over 2 minus root 2 over 2 squared. Very nice. So here, when I multiply root 2 over 2 to itself, I get 1 over 2 times 2 is 1 plus root 2 over 2. Here, this guy and that guy cancel each other and we have just 1 root 2 over 2. We can simplify this guy. Yes, I can write this as 2 plus root 2 divided by root 2. Or just simply root 2 plus 1. So our slope is that, and that's the key point because now the point that we are looking for is, well, theta is pi over 4 and r is 1 plus sine of pi over 4. Yes, and that will give me what? That will give me 1 plus root 2 over 2. And actually, while I can plug in, since I am going to write a tangent line in the Cartesian coordinates, so I need to find what is x, what is y. And this tells me that this guy is 1 plus root 2 over 2 times root 2 over 2. And this is 1 plus root 2 over 2 times, again, root 2 over 2. I can definitely simplify these guys. Let us see if I can do a good job here. So root 2 over 2 plus 1 over 2, and that is the same thing as this guy. So we have the point, we have the slope. I can go ahead and write the equation. So equation is going to be y minus y0 equals to m times x minus x0. So in this case, y minus root 2 over 2 plus half equals to root 2 plus 1 times x minus root 2 over 2 plus half. You can simplify that. I will leave it like that there. So the option for us is that the fact is that in general, the slope of the tangent line at tangent line to polar curve r equal to f theta can be calculated by the fact that we can turn this guy to f theta cosine theta, y to f theta sine theta, and then dy dx is going to be derivative of y with respect to theta will be f prime theta sine theta plus f theta cosine theta. And in the denominator, derivative of x with respect to theta is f prime theta cosine theta minus f theta sine theta. So that is the formula. You can either keep in mind or just use the trick we use each time and calculate the derivative at that given point. Let's do one more example here. Tangent line to the curve, this one. So r is 1 plus 2 cosine theta. And then we are looking for the slope, yes? I can use the formula we just wrote down. So dy dx is a derivative of this guy times sine theta plus that r itself times the derivative of sine, which is cosine theta. And the same story in the downstairs, but we have instead of sine theta multiplied there, we have cosine theta multiplied there, yes. Okay, so this gives me what? This gives me minus 2 sine squared theta plus cosine theta plus 2 cosine squared theta. In the denominator, we have negative 2 sine theta cosine theta minus sine theta minus 2 sine theta cosine theta. Okay, so let me just plug in then. Oh, okay, so I can simplify these guys. There are 4 of these, and I write negative 4 sine theta cosine theta minus sine theta there. So the slope is going to be negative 2 sine of pi over 3 is root 3 over 2 squared times 2 plus cosine of pi over 3 is 1 over 2 plus 2 times cosine of this is 1 over 2 squared. In the denominator, minus 4 sine of pi over 6 is root 3 over 2 times half minus sine of pi, this is root 3 over 2. Okay? So we can simplify this guy here. So I have root 3 over 4 times negative 2. This is negative 3 over 2 plus half plus 1 over 2. Yes, so that would give me in the numerator negative 1 over 2. In the denominator, I have negative root 3 minus negative root 3 over minus root 3 over 2. That will give me negative 3 root 3 over 2, which we can simplify and get 1 over 3 root 3. That is the slope. How about the point? Well, you just plug in r theta as that to cosine of pi over 3. This is 1 plus 2 times half. This is just 2. So r is that, cosine is theta is pi over 3, so then x is going to be 2 times cosine pi over 3, and y is going to be 2 sine pi over 3. So that is just 1. This is root 3. So the point now in the Cartesian, that's very important because we are writing the tangent line in Cartesian. It's 1 root 3. Slope is this guy. I can go ahead and write the equation for the tangent line. Y minus y0 equals to mx minus x0, which gives me y minus root 3 equals to 1 over 3 root 3 x minus 1. That is the equation we have there. Basically nothing new, but an old trick that we use, and knowing how to find the derivative or the slope of a parametric equation.